without the ability to analyze specific external content such as a link. A general discussion on evaluating electrical information for accuracy is important. It is essential to differentiate between established facts and potential misinformation. The realm of electrical engineering, like many technical fields, is subject to the spread of inaccurate data, flawed reasoning, and outright falsehoods. Firstly, it is important to understand the sources of information. Reliable sources typically include peer-reviewed journals, established textbooks, industry standards, documents from organizations like the National Electrical Manufacturers Association, or NEMA, the Institute of Electrical and Electronics Engineers, or IEE, and regulatory bodies such as the National Fire Protection Association, or NFPA, which publishes the National Electrical Code, or NEC. Government agencies also provide reliable data and guidelines. Secondly, consider the context of the information. Isolated facts, even if accurate, can be misleading if presented without proper context. For instance, stating the voltage of a particular electrical system, such as 480 volts, is meaningless without understanding the system's purpose, grounding configuration, and applicable safety standards. Thirdly, cross-reference information from multiple independent sources. If a specific claim is made, verify it against other reputable sources. Discrepancies should raise red flags. If multiple sources confirm the same fact, the likelihood of its accuracy increases. Fourthly, be wary of generalizations and oversimplifications. Electrical systems are complex, and many rules have exceptions or are contingent on specific conditions. For example, the ampacity of a conductor is not simply a function of its size, it also depends on the insulation type, the ambient temperature, the number of conductors in a raceway, and other factors. A statement like 12 American wire gauge (AUG) wire is always good for 20 amps is an oversimplification and could be dangerous. Fifthly, pay attention to units of measurement. The correct use of units is crucial in electrical engineering. A mistake in units can lead to significant errors in calculations and potentially hazardous situations. Ensure that all values are expressed in the appropriate units, such as volts for voltage, amps for current, ohms for resistance, watts for power, and hertz for frequency. Sixthly, understand the fundamental principles of electrical theory. A solid grasp of Ohm's law, Kirchhoff's laws, and basic circuit analysis is essential for evaluating the validity of electrical information. If a claim contradicts these fundamental principles, it is likely to be incorrect. Ohm's law states that voltage equals current times resistance, expressed as volts equals amps asterisk ohms. Kirchhoff's current law states that the total current entering a junction must equal the total current leaving the junction. Kirchhoff's voltage law states that the sum of the voltages around any closed loop in a circuit must equal zero. Seventhly, consider the qualifications and experience of the source. While anyone can publish information online, not all sources are equally credible. Look for authors or organizations with established expertise in electrical engineering. Eighthly, be skeptical of claims that seem too good to be true. If a product or technology is claimed to provide extraordinary performance or efficiency, exercise caution and seek independent verification. Ninthly, be aware of common misconceptions in electrical engineering. One common misconception is that higher voltage is always more dangerous. While high voltage can be lethal, the amount of current flowing through the body is the primary determinant of electric shock severity. Tenthly, understand the role of safety standards and codes. The NEC and other safety standards are developed to protect people and property from electrical hazards. Information that contradicts these standards should be viewed with suspicion. 11thly, learn to interpret electrical diagrams and schematics. Understanding how electrical systems are represented visually is essential for analyzing their operation and identifying potential problems. 12thly, consider the date of the information. Electrical technology is constantly evolving, so outdated information may no longer be accurate. Ensure that the information you are using is current and reflects the latest advancements in the field. 13thly, be aware of the limitations of online calculators and simulation tools. While these tools can be helpful, they should not be relied upon as the sole source of information. Always verify the results with other methods. 14thly, understand the difference between theoretical calculations and real-world measurements. Theoretical calculations provide a good starting point, but real-world measurements can be affected by factors that are not accounted for in the calculations. Always verify theoretical results with actual measurements wherever possible. 15thly, be cautious of relying solely on information from manufacturers' websites or product brochures. While these sources can provide useful information, they may also be biased towards promoting their products. Seek independent reviews and evaluations of products before making any decisions. 16thly, be aware of the potential for errors in online forums and discussion groups. While these forums can be a valuable source of information, they can also contain misinformation or biased opinions. Always verify information from these sources with other reputable sources. 17thly, understand the importance of grounding and bonding in electrical systems. Grounding and bonding are essential for safety and proper system operation. Misinformation about grounding and bonding can lead to dangerous situations. 18thly, be aware of the potential for harmonics in electrical systems. Harmonics can cause a variety of problems, including overheating of equipment, malfunctioning of electronic devices, and increased energy consumption. 19thly, understand the different types of electrical protection devices such as circuit breakers and fuses. These devices are designed to protect electrical systems from overloads and short circuits. Misinformation about these devices can lead to inadequate protection and potentially hazardous situations. 20thly, be aware of the potential for arc flash hazards in electrical systems. Arc flash is a dangerous phenomenon that can occur when electrical equipment is energized. Misinformation about arc flash hazards can lead to inadequate safety precautions and potentially fatal injuries. 21stly, understand the importance of proper electrical installation techniques. A proper installation can lead to a variety of problems, including electrical fires, equipment failures, and electric shock hazards. 22ndly, be aware of the potential for electromagnetic interference, or EMI, in electrical systems. EMI can cause malfunctioning of electronic devices and other problems. 23rdly, understand the different types of electrical cables and conductors. The selection of the appropriate cable or conductor for a particular application is crucial for safety and proper system operation. 24thly, be aware of the potential for corrosion in electrical systems. Corrosion can lead to equipment failures and other problems. 25thly, understand the importance of regular electrical maintenance. Regular maintenance can help to prevent problems and ensure the safe and reliable operation of electrical systems. 26thly, be aware of the potential for surge voltages in electrical systems. Surge voltages can damage sensitive electronic equipment. 27thly, understand the different types of electrical lighting systems. The selection of the appropriate lighting system for a particular application is crucial for energy efficiency and visual comfort. 28thly, be aware of the potential for stray voltage in electrical systems. Stray voltage can cause problems for livestock and other animals. 29thly, understand the different types of electrical motors. The selection of the appropriate motor for a particular application is crucial for energy efficiency and performance. 30thly, be aware of the potential for power quality problems in electrical systems. Power quality problems can cause malfunctioning of electronic devices and other problems. Evaluating electrical information requires a multifaceted approach, combining a solid understanding of fundamental principles with critical analysis of sources and claims. Reliance on credible sources, cross-verification of data, and a healthy dose of skepticism are essential for navigating the complex world of electrical engineering information. Understanding the NEC and its tables, such as Table 310.15b16, is key to proper conductor ampacity selection. For example, the table provides ampacities for various conductor sizes and insulation types at different temperatures. Similarly, NEC Article 250 covers grounding and bonding requirements, which are crucial for safety. Knowing these details allows you to evaluate claims more effectively.